Basic concepts of differential and integral calculus. Let y is equal to fx. X is independent variable, y is dependent variable. Thus, differentiation is a process of finding the derivative of a continuous function. Derivative or differential coefficient. First principle definition: derivative of fx is defined as limit del x goes to 0 fx plus del x minus fx upon del x. H or del x is small increment in x. So this term is derivative of fx with respect to x, or dy by dx, or f dash x, known as differential coefficient of fx with respect to x. Examples of a differential form of first principle. Example first: fx is equal to x square. We have limit h goes to 0 h plus x plus h square minus x square upon h, which gives h plus 2x. If we put h is equal to 0, then we get 2x. Example 2: fx is equal to a, where a is fixed real number. Using formula, we get fx plus h is a and fx is equal to a. So this gives 0 and the limit gives 0. As h is not equal to 0, it means derivative of constant is 0. Example 3: fx is equal to 1 upon x. Again, using formula or definition, note fx is equal to 1 upon x and fx plus h is equal to 1 upon x plus h. It means we get, note this. So we can write in this form. Next step is this, and implies these two get cancelled and we get, put h is equal to 0 and we get this. So we conclude derivative of 1 upon x is minus 1 upon x square. Some basic formulas: derivative of x raised to n is n into x raised to n minus 1. Derivative of e raised to x is e raised to x. Derivative of a raised to x is a raised to x into log a to the base e. Derivative of a is 0, a is constant. Derivative of e raised to ax is a into e raised to ax. derivative of log x is 1 upon x. Derivative of log x to the base a is 1 upon x into log e to the base a. Laws for differentiation. Algebra of derivatives of functions. Let f(x) and g(x) be two functions such that their derivatives are defined in a common domain. Then, first, sum rule, derivative of f(x) plus g(x), derivative of f(x) plus derivative of g(x). Second, difference rule, derivative of f(x) minus g(x), derivative of f(x) minus derivative of g(x). Derivative of f(x) into g(x) is derivative of f(x) into g(x) plus derivative of f(x) into derivative of g(x). Quotient rule, derivative of f(x) upon g(x) is derivative of f(x) into g(x) minus f(x) into derivative of g(x) upon g(x) square. Fifth, chain rule, where t is equal to g of x. Sixth, derivative of f(x) into c into derivative of f(x). Example, find f dash x. Fx is equal to 4x cube plus 3x square plus 11x plus 9. Let fx is equal to y. Then dy by dx is 4 into derivative of x cube plus 3 into derivative of x square plus 11 into derivative of x plus derivative of 9. This gives 3 into 2x. This gives 11 into x, 11 into 1, and this gives 0. Sum of all this gives 12x square plus 6x plus 11. So we get derivative of x is 12. Derivative of fx is 12x square plus 6x plus 11. Example 2. Fx is equal to a raised to x plus x raised to a plus a raised to a plus 3. First gives a raised to x into log x. Second, a raised to x, derivative of a raised to x gives a into x raised to a minus 1. Third gives 0. Fourth also gives 0 because both are constant. So we get derivative this. Example 3. Fx is equal to x square plus x square into log x. We take u is equal to x square and v is equal to log x. Remember, derivative of u into v is derivative of u into v plus u into derivative of v. Derivative of x square is 2x and derivative of log x is 1 upon x. So because of product rule, we use derivative of fx is x square into derivative of log x plus log x into derivative of x square into 1 upon x plus log x into 2x, and this get cancelled. So we get x plus 2x log x. That means x into 1 plus 2 log x. Now, derivative of implicit function. Consider following relationship between x and y, such x minus y minus pi is equal to 0. and second x y square plus 3xy plus y is equal to 0. In the first case, we can solve y and rewrite the relationship as y is equal to x minus pi. In second case, it does not seem easy to solve for y. Note, when it is easy to express the relation as y is equal to fx, we say that y is given as an explicit function of x, otherwise it is an implicit function of x. Now we will attempt to find dy by dx for implicit function fx y0. Example first, find dy by dx, derivative of y with respect to x, for x square y square plus 3xy plus y is equal to 0. So derivative gives x square into derivative of y square plus y square into derivative of x square, and 3xy is a derivative, it's 3x into derivative of y plus 3y into derivative of x, and derivative of y is equal to 0. This gives this, and this 3y into 1. Note, derivative of x is 1, derivative of y square is 2y into derivative of y. Now we common out all derivative of y, plus 3y is equal to 0. dy by dx gives this, the final answer. So we get from this. ये हमारा फाइनल आंसर है. एग्जाम्पल 2, y क्यूब इंटू एक्स रेस टू 5 इज इक्वल टू एक्स प्लस वाई रेस टू 8. हमें फाइंड करना है dy by dx, differentiating on both sides we get implies this, then this thing combining these two and combining these two get this. So we just shift this thing to denominator, this thing, तो हमें डिनोमिनेटर के डालने के बाद यह मिलेगा. तो डेरिवेटिव ऑफ y ये आता है विथ रिस्पेक्ट टू x, और इसे ही हम इस तरह से भी लिख सकते हैं. तो इस न्यूमरेटर का हमने फिर से इस तरह से लिखा, और बाद में डिनोमिनेटर को इस तरह से लिखा. तो ये दोनों कैंसिल हो सकते हैं. तो इसे हम फर्दर सॉल्व करते हुए ये मल्टीप्लाई करके x और y न्यूमरेटर और डिनोमिनेटर से अलग करके हम इस तरह से लिख सकते हैं. अगेन सो न्यूमरेटर और डिनोमिनेटर कट गए, आखिर में y upon x are. So we conclude derivative of y with respect to x is y upon x. Thank you. Please do subscribe to my channel.